Hey everyone, this is Ron Pereira from Gemba Academy, and I'd like to welcome you to today's webinar focused on how to use SPC to make better management decisions. So before we get started, let's go ahead and just cover a few housekeeping items. So we want everyone to ask questions, and you can do that in two ways. There's a little question box in the webinar control panel to your right, so you can go ahead and type questions in there, or you can also email us at academy@gembaacademy.com. And if you can't remember that, you can always go to Gemba Academy's website and just click the contact tab at the top of our website, and that will come straight to us. As far as the audio goes, in the slides, you can enlarge the slides like you would a PowerPoint presentation, and be sure to adjust the volume on the webinar and also on your computer's master volume control. Now, we will have a recorded version of this presentation available within 3 days. And our presenter, Mark Graben, is going to be kind enough to share his slides as well. And last time we did this with Mark, we did that through SlideShare, so it's a really nice format to share PowerPoint slides. So we'll go ahead and send the link to that out as well. Okay, so let's go ahead and talk a little bit about Gemba Academy. So for those that don't know, Gemba Academy, we produce online and DVD-based lean enterprise training. And there's three entities that started Gemba Academy: the Kaizen Institute, Factory Strategies Group, and LSS Academy. And as of today, we have over 230 lean videos covering lots of topics, everything from 5S to lots of discussion on things such as the 7 QC tools, which Mark's going to talk a little bit about today. And on the next slide, we are running a promotion this month whereby anybody that buys a online subscription gets all of our DVDs on 34 DVDs for free. So if you want to learn more about that, go to gembaacademy.com and check that out. So let me go ahead and introduce today's presenter. So Mark Graben is a consultant, author, keynote speaker, and blogger in the world of lean healthcare. In June of 2011, Mark joined the software company KaiNexus as their Chief Improvement Officer to help further their mission of making improvement easier in healthcare organizations. Mark is also the author of 2 books. The first, called Lean Hospitals, was selected for a 2009 Shingo Research and Professional Publication Award and is being translated into 7 languages. Mark's second book, titled Healthcare Kaizen, Engaging Frontline Staff and Sustainable Continuous Improvements, is due out in April of 2012. Mark is also the founder, lead blogger, and podcaster at leanblog.org, which he started in January of 2005. And finally, Mark earned a BS in Industrial Engineering from Northwestern University, as well as an MS in Mechanical Engineering and an MBA from the MIT Sloan Leaders for Global Operations program. So, without further delay, I'd like to go ahead and turn things over to Mark.
Well, thanks, Ron. And speaking of further delay, I need to go and update my bio because, as it says here on screen, I think the new book will be out in June 2012. We're still going through editing cycles, which a lot of lean thinkers would call rework, but that's the way publishing goes. But I'm very happy to be here today. Thank you to Ron and Gemba Academy to talk about some tools I've used through my whole career. SPC, Statistical Process Control, and how to use that to make better management decisions. Now, I started my career as an industrial engineer at General Motors. They had control charts in the SPC methodology. They weren't really used to make management decisions, which is a whole different issue. But as I've gone through my career, I've used that approach, and I think it's very applicable in looking at all sorts of data in different types of industries. So I'm going to share some examples from healthcare and different settings that I think help us answer some of these key management questions. Because we don't want to do SPC just for the sake of doing control charts. We need to be able to answer questions such as, how are we performing? Are we getting better or getting worse over time? And then based on that determination, what actions should we take or sometimes not take? What kind of investigation should we do given a particular view of the data? And I'm going to try to show you today how I've used SPC in some ways that I think are helpful. Because one of the people who worked with the great W. Edwards Deming, Dr. Lloyd Nelson, as he said it, failure to understand variation is a central problem of management. He's one of ASQ's, he was our 20th honorary member, recognizing his great career. So in terms of talking about variation in a system, variation in data, I'm going to reference my favorite book ever. People might say, well, that's not a book about lean. There's a lot of books about lean that I love, but my favorite book that I've gotten the most use of, and I've given by far more copies of this book away to people I know and work with, is by Professor Donald J. Wheeler. His book's called Understanding Variation, The Key to Managing Chaos. And I think a lot of us in different industries and different settings are trying to get a handle on chaos. And we want to manage smartly in these environments. And Dr. Wheeler gives us a lot of very practical tools and methods to help manage better. And one of the things Dr. Wheeler always says, and I found this very helpful, is the idea that no data have meaning apart from their context. And I think a lot of us are in environments where we have computer systems, we have tons of data, but data doesn't necessarily equal information. And I think as people would tend to say, information doesn't necessarily mean that we have wisdom, meaning that we know how to interpret that data, to put it in context, and to know what kind of decisions to make. So as an example of data that is extremely far apart from its context is something that was part of a display in a public lobby of a hospital for patients, for visitors. And one of the things that this hospital tracked, and you can see it's on display here, is some mysterious thing called a quality panel score. Now I tell you, as an outside visitor, even someone who works in hospitals, I don't know how you calculate a quality panel score, and visitors certainly aren't going to know what that means. So how is this supposed to be helpful to the general public? What's the scale? What's a good score? Is 10 a good score? Is 5 a good score? Is 1 a good score? What's that score compared to? How's that compared to other organizations? So looking at this, I can't tell you if this is based on this number, a good hospital, an average hospital, or a hospital you would want to run away from. Why is the target the way it is? In a lot of cases like this, the target is suspiciously close to the actual number. A target of 3.59, the actual is 3.58. I mean, if somebody was just completely flat out fudging that number, I guess they would show the actual is 3.60. Or maybe one, if one's a better score, maybe they did it exactly that way. But in a lot of cases where we have these numbers that are pretty much the same every year, we get really good at setting targets that we think we can hit. So either way, comparing a number to a target provides very little context. And so does comparing any single data point to last year or last quarter. And we do this a lot in our organizations. We often see this in the news. So here's an article from the end of last year, USA Today. The headline says, 19 states see a jump in traffic fatalities. But now, we look in the article and it says, well, traffic fatalities dropped for the 5th straight year in 2010. So do we have a big increase, or are things declining? A single data point or even a little bit of text doesn't really let us see if, as the article says, is this a blip or is this any sort of long-term trend? So the fact that data quote-unquote jumped, or that it went up 2.9% overall, doesn't necessarily mean that things are trending in a less safe direction. Now if you look at Connecticut, so the biggest jump was 42%. Are the roads in Connecticut 42% more dangerous than they were in the last year? I mean, maybe everybody went out and bought mobile devices and they're texting and driving a lot more. I don't know. But this type of simple comparison makes for a great headline, but it really gives us far less to work with in terms of how to manage. So I actually went to the NHTSA website and pulled all of the data, at least going back to 1995, looking at the U.S. and for Connecticut. And so now, this simple chart, this run chart, it's not even an SPC treatment of it yet, gives us far richer information that I could look at this and say, you know what, the roads in the U.S. are trending safer over time. I can say that pretty certainly. Now, Connecticut, the thing that's interesting is that the big jump up from 2009 to 2010 is preceded by a big drop from 08 to 09. So if you look at that whole set of data, that might be slightly decreasing over time. It may be a stable system, but we look at it and say, well, maybe something's faulty with the 2009 data that led to that drop and then that spike. So when we look at charts, we can see a lot more, even if it's not a formal SPC chart. So we need to look for trends, and somebody quoted in one of these articles, I think, nailed it perfectly. You don't want to make a big conclusion based on just 1 year, because if we're jumping the conclusions, it's like the guy from the movie Office Space, if you remember his jump to conclusions math. You know, are we going to go and punish somebody based on 1 year's worth of data, or reward them if it's something that's really not a statistically valid trend? I would argue we need to be careful about that. Now, I don't want to, I'm taking a risk showing some political data, but if we look at variation in a single set of numbers or a single comparison, in the political world, they actually do, and the media often helps create a better job of the variation that's often inherent in data. When we see somebody's approval ratings, they show the statistical margin of error, plus and minus 3%, which, if you know something about statistics, tells you that this person's approval rating might be 38%, it might be 44%. If you took that same survey a bunch of times, there's going to be variation in that data. And in a lot of our data in the workplace, there's variation because that number is being generated by a system where there's variation. So if we had a patient satisfaction score of 90%, the exact same system that we work in could have just as likely generated a patient satisfaction score of, say, 87% or 93%, but hospitals very rarely, when they present a number like patient satisfaction percentage, give us a plus-minus error, because we know that the numbers could look like this, that if February and March both had a plus and minus 3% error, that what looks like a big drop might really be kind of a small drop, or maybe it's something that altogether isn't newsworthy. Now, when I worked for a manufacturing company, this is going back about 10 years ago, we logged into our computers, we had what they call a splash screen, which would throw a bunch of data points at us. This is just one of those charts that would show a number of things, including one on the left, this STT means ship to target. Were we shipping to our customers on time? And so, especially with all four of the charts for different things, for different regions, it was really overwhelming. But if we look worldwide, ship to target, the blue, it looks like it increased about, 4% over the previous year. And we're nowhere close to, somebody set a goal that we were going to improve that by 35%. Whether that goal was based on reality or not, who knows? That's one of the problems with goals and targets. All we know from this chart is that we're doing 2%, 3%-ish better than last year. So to ask that question, are we improving, it's really hard to answer that question. So if we look at a chart, and I forget who came up with the term, but somebody called this an executive time series. If you think even statistically 2 data points don't make a trend, if we take that number, and it was a 4% difference. If the baseline was 100, 2000 was 104, are we getting better? A simple analysis, well, yeah, of course, we're 4 better. Kind of like the guy in Spinal Tap he talked about, yeah, that speaker is 1 louder when it goes up to 11. It's 4 better. Is it really better? This executive time series isn't taking into account the way political polling does, of saying, well, what's the plus minus? So if we looked at plus and minus ranges, again, the same systems from 99 and 2000 could have created a range of data where maybe within those bands, yeah, maybe we did get better from year to year. Or, you know what, maybe it's possible that we got worse. We don't know with just 2 data points without that context. So if you look at a run chart, and this was real data, I was able to go and look at month-to-month data that was available to us. And now when we put it in terms of a run chart, we have more context, and I would look and say that, yeah, I don't know for a fact we're improving. It looks like kind of a statistically stable process. And if we were to make an SPC chart about this, as I will later, we'd be able to better gauge to that question of, are we improving? And now even if we do run charts, we need to be really careful that we avoid bad conclusions. So there was a consulting case study that I read going back a year ago, and I blogged about this. It said in the report very definitively, the average patient satisfaction increased from 87.2 to 89%. Now, part of me looks at that and says, okay, well, big whoop. 2%, that sounds like it's within the margin of error. But they actually created, to their credit, and they shared a chart that looks like this. And I said, well, wait a minute. That looks like a statistically stable, in-control process where they kind of cherry-picked, I think, a number toward the beginning and a number toward the end that says, oh, yeah, we're improving. You should hire us. If they had chosen different data points or maybe hadn't let this time series run as long, if you cherry-pick the point from 87.2 to 83.4, you might say, well, patient satisfaction got worse. But I think what we're really looking at in a case like this is noise in a system, and we want to be careful about not jumping to conclusions or making bad conclusions off of data like that. Now, another thing we see not as effective as run charts or SPC charts, or something organizations, I think, wrongly call a dashboard. So here's an example. This is from a hospital operating room suite, their surgical dashboard. Like, my goodness, this is just packed full of data. We've got lots of numbers, but again, people are generally pretty bad at detecting trends in a table of numbers. This is a point Dr. Wheeler makes really well in his book, that instead of a table of numbers, we need to present charts because charts are visual. And people tend to make better conclusions based off of a visual treatment of data, not this quote-unquote dashboard. You know, if we're going to use management dashboards, I mean, I think a better dashboard, this is my car, is a dashboard is simple. You know, it presents, you know, just the limited information that you need to make good decisions. I don't need to know 100 different, excuse me, 100 different data points about my car. I need to know, am I driving too fast? Do I need to slow down? Do I need to stop and get gas? You know, very limited information. Again, making decisions. That surgical chart, that dashboard makes it really hard to make decisions. So we want simplicity, not this complicated, complex dashboard. If you remember the show Knight Rider, and it probably looks like that I lost a bet and had to somehow incorporate Knight Rider into a slide, but here it is. Our friend David Hasselhoff, not a great lean thinker as far as I know. So again, we don't want overwhelming data. We don't want the Knight Rider dashboard because we can't see trends off of that. And even if we blow it up and look at one line item, again, really hard to see trends. Can we predict September's performance based off of these trends? And one great lesson from Dr. Deming was that he always said, management's job is prediction. That if we can't predict the future, then we're going to have a lot of problems. And it's not that we have crystal balls, but when we look at SPC charts, when we have a stable process, it allows us to a reasonable expectation, predict the future, that our data will fall in between these two ranges based on that past stable system, unless something changes. So we can do a lot better than this kind of overwhelming data. So the good news is that there's a better way. We think about statistical control charts. How do we have a better understanding of our process, what people would often call the voice of the process, and how do we make better decisions based off of these charts? And the good news is that, no offense to any black belts or master black belts, the good news is that you don't have to be a black belt to be able to make a simple control chart. That again, even back in my General Motors days, the people on the assembly lines could create control charts. Now, they probably had somebody helping them in terms of drawing the control limits. Now, what they needed help about was from leadership to make sure that we could actually take proper action based on what that voice of the process was telling us through the SPC charts. And so here's an example. This is what we would call a control chart for individual values, or an X control chart from Dr. Wheeler's methodology. So here's a time series of data in that blue line, and then we have the green line on this format that shows the mean, the average, which is an easy calculation. And then going above and below, we have what we would call 1 sigma, 2 sigma, and 3 sigma control limits that represent the standard deviation of a process. So we have upper control limits, we have lower control limits. Now, in a lot of cases, I don't always draw the 1 and 2 sigma control limits, because if you have just your 3 sigma, 3 standard deviation, upper and lower control limits, that tells you a lot about a process right there. And you can sort of learn to eyeball it if we've got data that is hanging out in a range that indicates there's a signal of something happening in our process. So a chart like this plots the data. In this case, this is a hospital laboratory, and their daily average potassium test turnaround time. And the number of samples and tests each day was pretty much the same. There's different forms of control charts that take into account sample sizes and other factors. So whether, even if it's not completely statistically correct 100%, I found that the individual value control charts are very helpful across a wide range of data for helping us make decisions. And looking at this control chart, I see that the process looks stable, that we can pretty well predict that tomorrow's average is going to be somewhere between 30 and 62 minutes, and that the average is about 47 or so. Now, this might, we might not be happy with the level of variation in the system, but any particular up and down from day to day we would consider that to be noise in the system. So if we say, what happened yesterday? Doesn't mean anything happened. It's all part of that same system. That variation, that common cause variation, that if you look at political polls, could be the difference between 47 and 44% approval. There's noise in the system, and as managers, we don't want to overreact to that noise, and I'll share some examples of that later, because for one, we're probably wasting time as managers, and we're driving our people nuts if we overreact to noise in the system. Now the other thing, not drawn here, and I tend to not draw goals or targets on a control chart, because it confuses two things. The goal might be arbitrary, or it might be the voice of the customer saying, we would like an average turnaround time of 25 minutes. So what this control chart, though, in comparison to the goal, what it tells us is that the system is stable, but it's not capable. And that there's different ways of trying to go and improve the system, knowing that on average it's stable, it's not meeting customer needs, as opposed to having a system that is out of control and had something weird happen yesterday that drove average turnaround time to 80 minutes. Then as managers, we don't want to jump in and find out what happened, quote unquote. So if you look at the noise in the system, like Dr. Deming said, every system is perfectly designed to get the results it gets. This system is perfectly designed to deliver an average turnaround time of about 47 minutes. We need to change the system if we're going to get to that goal of 25 minutes. We can't just lecture people or browbeat them and say, hey, go get better. We need to hit that goal. We need to understand the system and improve accordingly. Now, statistically correct treatment of this approach would be to draw not just the X chart that shows the daily averages, but to also show, and I'll explain this and show a detail of creating a chart, what we call an MR chart. So the MR is the moving range in the day-to-day values, which is another way of looking at our variation. So we might have a system that's in control because the daily averages are always within this expected range. But if we had too big of a jump day-to-day, as we see here or see here, that might be another signal that there's something worth investigating, again, as opposed to being noise in the system. And we can evaluate all sorts of pieces of data. I was actually working with a friend looking at a local business here in Texas. And I've blinded the data a bit, but we're looking at monthly revenue for this business in a control chart. And it looks, if we look at the X chart, it's pretty much stable and in control. And I'm going to show you later what some of these rules are that we would use to evaluate this. Looking at the MR chart, you can see where we've got this spike where we had a big up and down from month to month, which indicates that something special may have happened, that it wasn't just noise in the system. It's unlikely that we would have just randomly, within that stable process, had a big jump and then a big decline. So when we have that point, we might go and talk to the managers or the owner and say, was there anything you did differently that month that drove revenue that high? And then, did you stop doing that the next month? So you can start detecting, what are the things that are happening that are maybe impacting our business in a good way or in a bad way? We see that out of control point on the MR chart. Because if we look at Deming's, what we call the 7 concepts of variation, and I'll just go through this briefly, that all variation is caused, but there's different causes. we'll go through these 4. So think about, if you're doing an SPC chart on how long it takes you to drive to work every day, and unlike the picture, don't build the spreadsheet while you're driving, please. She must be in a parking lot. But we build a simple spreadsheet that shows, okay, on average it takes 22 minutes to drive to work. But there's a range. There's what we would call the common cause. Did we hit a light or not? Just variation in normal traffic. There might be a range that says, if it takes us anywhere from 17 to 25 minutes to get to work, that's the common cause variation. And if we absolutely have to get to work on time, we probably better plan on at least a 25-minute commute so that we're accounting for that common cause variation. Now, if there was a really bad jackknife truck on the way to work, if there was a really bad snowstorm, and it took us an hour to get to work, something like that would be what we call a special cause. We can attribute that unusual variation to something that happened. And our goal in organizations is to make sure that if we have a special cause, that we can find it and that we learn about it. Then we have what Deming called tampering. And that's what happens when we mistake common cause and special cause. When we see a stable system, when we ask, hey, what happened yesterday? And we have people go and waste time looking for what happened. Maybe people start kind of gaming the system and tweaking the system to show the number that they think we want. There's dysfunctions that can come from that sort of tampering. And then there's structural variation, which might be seasonality in a business, for a hospital or for a local business. Managers have to distinguish amongst those different types of variation to make good decisions. And I'm going to skip through this slide, but it'll be in the handouts, and you can go and research Dr. Deming and learn more about these ideas of variation. But just 2 quick points. For special causes, we want timely data so that we can go find out what happened. Not last month, not last week, ideally, yesterday, or in some businesses, last hour. We need timely data. For common cause variation, it's much more complex, and this is where we can use lean methods, Six Sigma methods to go and better understand that system so that we can improve it. Now, one great illustration of what we call common cause versus common cause variation that can be impacted by tampering is the famous funnel experiment that Dr. Deming always talked and wrote about. The idea that you suspend a funnel on a stand, you drop marbles, and they hit the ground and they roll somewhere. And if you do this for 50 marbles, you're likely to get what we call a stable system. That the marbles hit and they tend to fall within a certain pattern. A stable system, again, doesn't mean that we have 0 variation, and it doesn't mean that the system meets customer requirements. It only means that the causes of variation are constant over time. The type of carpet we have, the distance we're dropping the marble, the type of marble that we have. And so a lot of times when we have a stable system and that noise in the system, we tell people, we got to try harder. We got to be doing something. We want all of those marbles to hit and land on their target. And if you want to spend more time playing around with this, there's a great online simulator that you can either buy or you can use it for free on a limited basis if you go to this website here. But in the classic funnel experiment, there's 4 different things that you could do, and I just want to illustrate 3 of them. If we make no adjustment versus making a small adjustment relative to where the marble fell, what we call Rule 2, you can see that tweaking of the system actually increases the variation in the results. So when we have systems where we talk about constant adjustment or constant calibration, on the machining lines at General Motors, constantly tweaking the machining based on the last part you made increases the variation in quality to the customer, which is kind of an unintuitive thing. And then there's a different rule we could use when we talk about adjusting the funnel in a different way, where instead of a stable system with a little bit more variation, we suddenly get a wildly out of control system that has a lot of increased variation. So the question is, if we have a stable system, should we do nothing? Dr. Deming, he's always the contrarian, and he said, sometimes don't just do something, stand there. And I think even this is a picture, we rarely see pictures of young Dr. Deming, younger Dr. Deming. Dr. Deming's point was that we can't always go running around looking for a special cause if the special cause isn't there. And if we constantly tweak and overreact to a system, we might actually be making things worse. And so here would be an example. If you look at, let's say, daily production numbers in a system, the average daily production. We may have a goal of 42, but again, that goal might be completely disconnected from the stability of our process. So let's say we had an increase from day to day. Traditionally, a manager might say, "Yay, way to go, everybody." We praise the team for their improvement and for their good results. And then we see performance drops. Now, a traditional-minded manager looks and says, well, when I praise my team, they get full of themselves, they slack off, their performance got worse. So I'm going to go kick some butt and say, hey, go get better, people. And we may see an increase, and the manager comes back out and says, hey, way to go, everybody. I think we got things turned around. We're heading in the right direction. We're getting better. And then performance drops. And so we go out and we kick butt again, and things get better. And we say, oh, hooray, and then things get worse. So I think we have these questions to say, well, if that's our behavior as managers, are we helping? Are we really helping? We're arguably overreacting to a stable process. And all the praise and the butt kicking or the motivation or the reinforcement, we may be just wasting our breath. So let's talk briefly about creating a control chart. You can do this in your favorite statistical package. I tend to just bang out a quick spreadsheet when I need to put together a control chart. But if we want to create a simple control chart that has, again, our data points in blue, an average line, and simple 3 sigma upper and lower control limits, we can make that pretty easily in Excel. So just to show a different type of data set, I actually went and pulled the weekday blog traffic for my site at leanblog.org. I excluded weekends because I know there's kind of a structural reason for that variation of why fewer people are reading a blog about lean on the weekends. So if we look at the weekends and say, well, if I'm managing my blog, how do I know if traffic is increasing or decreasing or if it's stable? So generally we need 20 data points to calculate those initial control limits. So I went back to the beginning of the year and pulled the data set that you see here. Then we go and we calculate an initial mean or average and the moving ranges for those data points. So you can see here, this is just a simple average calculation. And then here for the moving range, I've just set up a simple formula of the absolute value of one day minus the last. So we've got columns now of the average and of the moving range. And so the first thing I'm going to do is draw the initial chart of the data with the line there that's the mean. So in my first analysis here, I'm looking to see, do we have roughly a mix if this were a stable system of lines above and below the average? Are there clusters? Are there trends? At first glance, I'm like, well, I see a bunch of points here that were below the average. What's going on there? And if we go and add the control limits so that we can evaluate that, I'm adding columns in the spreadsheet. The one thing we do is calculate what we call the MR bar, the average of the moving ranges, which is 270. And then our lower and upper control limits are calculated by taking the mean plus or minus 3 times that MR bar divided by 1.126. So you could just have a formula, I think it's 2.68. You could just say plus 2.68 times the MR bar, but what the 3 represents is basically 3 standard deviations. So that if you want to do the 1 sigma and 2 sigma control lines, you just replace that formula with 1 or 2 instead of 3. So once we've got that spreadsheet and we've added those lines to the control chart, now we've gone from a run chart to a control chart, I see what looks like maybe a special cause. Here's a weekday where blog traffic dropped pretty significantly. This is unlikely to be caused by noise, by just normal variation in the system. And so I went back and I looked at the day of the week. This was actually the day when there were a lot of people online protesting the proposed SOPA legislation, SOPA and PIPA. So actually I shut down my blog for half a day. I'm like, that's why. My traffic was really low because the blog was down. People couldn't load pages. So I've identified the special cause, and I don't need to worry that I wrote about something that was offensive or wildly unpopular, that there's a good, reasonable special cause that I could identify. So the next thing you're taught to do is to go back and, for those initial control limits in the initial mean, we want to exclude that initial out of control point. And so then when we redraw the control limits, we've got something where we see roughly half the points above and below the mean. But now we've got a point here that looks out of control on the lower end, and a point here that's out of control on the upper end. And I said, well, what happened? Well, this first weekday of the year was actually a holiday. It was January 2nd. So I'm like, well, you know what? That's a special cause, I understand. Blog traffic is always low on holidays. I'm not going to really worry about what happened there. I can't really go back and figure out why traffic was high here on this day. So when we don't know the special cause, we, in our system, may lose an opportunity to capture that knowledge. So like if this was laboratory testing and we have special cause of a good turnaround time that's out of control in a good way, we want to understand that, so hopefully we can go and keep doing that thing we were doing that day, to not just have it be a fluke, but to have it really be a change to the system. And then, you know, I stopped tweaking the control chart, but I think you can see what happens as we start. I stopped tweaking the limits, but as we evaluate this over time, and this is what we want to do as we're managing a system in a control chart, here we have more out of control points in the positive side. And we also start looking not just for points above and below the control limits, but we look for trends. And so one of our control chart rules is having points above and below the average. You can see here I had a streak of, I don't know, 15 points above the mean. It's unlikely that this is caused by statistical chance, that there's likely some systemic change that boosted blog traffic over time. And I think what happened actually is that Google changed something in the way my search results show up within, my site shows up in their search results. So there's actually kind of, I think, a systemic thing that happened that is bringing more people to the blog. And so now from that, I'm going to go and calculate new control limits because the system is different than it was before. A system with a different, as they call it, Google page rank. That system has changed. My blog and what I'm writing, and you know, that's the same, but part of the system that brings people to my site has changed, and the new average and the new control limits reflect that. So if in the past I could have expected on average anywhere from 1,000 to 2,200 page loads on a day, now in this new system I can predict that it's likely to be between about 1,500 and 2,500, and that I shouldn't overreact to every up and down in the data and think about my blog in that detail. If I was looking at data, daily revenue for a business or daily production numbers, kind of the same thing applies. I don't necessarily want to overreact to every up and down in the system. Control charts allow us to see the signal through the noise. And there's more rules, what we call the Western Electric rules, which you can find online. There's a short link to that. Some of those rules include 8 consecutive points on the same side of the mean. So that's what we saw in my blog control chart. That's a sign, a signal that there's likely a special cause. If we have 6 points in a row moving up or down, again, that's unlikely in a stable system unless something happened. 14 points in a row that are up, down, up, down, up, down, up, down. Again, that's unlikely due to statistical chance. We may find when we have these up, down, up, down, up, downs that somebody's maybe gaming the numbers, or we've got kind of 2 different run charts kind of mixed in with each other. So let's say if somebody was charting production by shift, maybe they shouldn't be doing that because maybe it's day shift, night shift, day shift, night shift, day shift, night shift. Maybe they should really break that out into 2 separate control charts for each shift. So we can evaluate, you know, when we're looking at control charts over time, are we improving? So here's an example. This is some laboratory data again, daily turnaround times. The green bar represents in time where we made a very systemic change to the process. So sometimes with control charts, we're looking at the charts and using the chart to kind of give us hints, did something happen or not? But here we know something happened, so we can use the control chart really as a way of testing that hypothesis that with this new laboratory layout, turnaround times would drop. And so as we look at the data points over time, we can see that, yeah, that looks like a statistically significant change because we've got a bunch of points all in a row that are below the mean. We've confirmed that we have a process shift. We could probably say pretty definitively, turnaround times improved in this lab. And we could redraw the control chart limits to show that new system. Our expectation is that the average turnaround time now is probably about 14 minutes, not 19 minutes like we had before. And I've also used charts like this. I've had clients that I've kept in touch with over time. This is one hospital's laboratory results. This is now looking at monthly data. They look at their data daily, which again, going back to Deming's lessons, if they had a special cause, they're going to detect that within a day if their system had changed for the better or for the worse. Here I'm just kind of evaluating this over time. And again, instead of not having, I don't have the control limits here, but the green lines represent the means. This gives me some sense, and I think more statistically valid than a linear trend line. Are we improving or not? So, here's turnaround time. It was pretty stable over a period of time, and now here's a process shift. And if we were looking at the MR chart, we'd probably see that the month-to-month variation also decreased significantly. Not just the average, but the variation. We see the same thing in this turnaround time chart. We actually had 2 separate drops over a period of time. Down here in the lower left, this is a measure that we want to be higher. The percentage of test results that are on charts by 7 a.m. That's actually had a couple of jumps. And then here in the lower right is a productivity metric where you can see the average has dropped down. Now this is where if we had the MR chart, this big jump here is probably an out of control point. You'll say, well, why did productivity drop for it looks like a couple of months and then jump back up? Or actually, productivity was better, here with the lower number. And then here, why did productivity get worse? We want to be able to ask and answer those questions so that we can manage these systems properly. Because again, not understanding this variation and not managing it properly is really going to cause a lot of frustration among your staff. If we're pressuring people to get better results by working harder within the same system, that was the way they managed back in my days in the auto industry in the mid-90s, that didn't work because people, if they have a system and you're not helping them change the system, they're not going to do better by just working harder. And I think here's another key thing is managers, we're so busy. People always say, we don't have time to do lean. We don't have time to do Kaizen. If we're wasting time running around looking for explanations of a special cause when it's not there, we can save ourselves and our people a lot of time by using those control charts to help gauge the questions that we ask, to help guide those questions. We might take actions when it would have been better to do nothing, and we might not focus on the systemic improvement. So, again, reducing the mean of that lab turnaround time meant changing the system, changing the layout, changing our process, not just saying, hey, do better on a given day. My final example, and we'll actually have some good time here for Q&A. This is a board, this is a laboratory that I worked with that switched from just really lagging monthly performance measures to looking at some of their key indicators on a daily basis. Now, this dashboard may look a bit like Knight Rider, but they were doing separate charts for all 3 shifts, and they picked a couple of key indicators for each of those shifts. And they would do daily huddles around this board. So they were looking at it and saying, where do we have what looks like a special cause versus day-to-day fluctuation in these numbers. Here you can see on this chart, those are probably special causes, even though they didn't have control limits on the chart. We did a lot of training to help people kind of help gauge what looks like noise and what looks like a signal. So again, that's probably not the most pure approach to this. And again, they weren't doing the MR charts. I tried teaching them that. They said, let's just get going with run charts and we understand a little bit more about SPC. So after managing this way for a while, one of the technologists in the lab, when I was back on a visit, came and told me a story. And he pulled me aside and he said, we're looking at the numbers every day, and we appreciate that when we have a bad day, the managers are saying to us in the team huddles, okay, so we had a bad day yesterday. Don't worry about it. We know it's the system. We're not blaming you. And he said, but when we have a good day, the managers pat us on the back and they clap and they applaud and they say, way to go. And this technologist said, isn't it always the system? Whether it's a day that's a little bit better or a little bit worse. And so what they found was that the pats on the back, when they weren't there, felt like a kick in the butt. Even though the manager said, oh, bad day, don't worry, it's the system, the lack of praise kind of stung. And the technologists had an even a better insight where we could reinforce to the managers that, you know what, it's almost always the system. Don't overreact to the noise in those charts and say, way to go, what happened? It is what it is. The average for a certain type of test might be 6.7 minutes. Unless that daily average drops to 1 minute, which is probably just unrealistic, or if it jumped to 20 minutes, then that can guide our investigation, our troubleshooting, our communication of what to do to better manage that system. So I hope this is helpful. Again, I encourage you to go to Dr. Wheeler's book and get a copy. I think it's available on Kindle. And learn more about this and experiment with it. And hopefully you'll find that it helps you make better management decisions. So here's my contact info. Before I turn it back over to Ron for some Q&A, here's my email. If you've got ideas, if you've got questions, if you want to criticize some of the statistical validity of what I've done, let me know, because for one, I want to learn from those of you who are better at statistics than I am. Or if there's things I need to do to tweak the methodology, I'm certainly open to that. Here's the blog, here's Twitter. And then with the books, Healthcare Kaizen is supposed to be out in June. If you go to hckaizen.com, in the lower right corner of the main page, or if you click in the menu where it says free first chapter, you can download. It's a preview of what that first chapter is, and it also includes a summary of what's included in the rest of the book. So I would love to hear your feedback and your thoughts about that, this book that I've written with Joe Schwartz from a health system in Indiana. So thank you for joining today. And with that, Ron,
all right,
we'll do some Q&A.
Oh, wow, well, great job, Mark. Got lots of praise already here, and they're not necessarily all questions. There are a lot of people saying great job. So nice story by JD. So good stuff there. So I got questions coming in over email and also through the webinar. So I'll try to balance between both of them. So the first one is an interesting question, and I'm just going to paraphrase it because it's pretty long. But the gist of the question is that those practicing lean are often we spend a lot of time talking about tools such as value stream mapping and 5S and one-piece flow, but the gist of the question is, why isn't SPC talked more about within the lean world?
Yeah, that's a great question. I mean, I had somebody. I tweeted about the webinar, and a friend of mine who's been in manufacturing for many decades and is a bit of a contrarian, he tweeted back, and it's like, oh my God, I thought SPC was a fad of the 1960s. I'm surprised anyone's still talking about this. I mean, if it's a lost art, that's a real shame, because when I was at General Motors in the mid-90s, control charts predated anything they were even trying to do with lean. And maybe SPC has become the domain of Six Sigma. It's a real shame, because even if we're not practicing full-blown Six Sigma, to use the simple basic QC tools and to have basic statistical literacy, I think it's an important thing. That's why I included a little bit about SPC in my book Lean Hospitals, and certainly. Anytime I've worked with anybody trying to do something with metrics, I let them borrow or get them a copy of Wheeler's book, and we go through that together and try to understand some of those basic lessons. That's why I'm passionate about the topic and wanted to do the webinar for Gemba Academy to get more out there about this and help people see that it doesn't have to be super complicated.
Okay, very good. So we are officially being overwhelmed with questions. So I can, well, so what we're going to do is we'll cover a few more here within the next 10 minutes or so. But Mark and I will do Mark's a professional podcaster, as many people know. So Mark and I will do a follow-up podcast, and we did this last time. He did a webinar where we can go through as many of these questions as possible. So keep sending them, but please don't be upset if we don't answer them here on this live webinar. So. Next one, let's see here. Here's a good one. Sandeep wants to know, how do you differentiate between noise and signal?
Right, well, and that's where, the Western Electric rules help us detect that. So when we look at a control chart and there's a variation, a point outside of the 3 sigma control limits, we would call that a signal. 8 points in a row above the average, we would call that a signal. And there's a broader list of those Western Electric rules. I tried to do just the simple introduction, but those rules tell us when we have a signal. Now, with statistical variation, there's always the chance that the chart tells us there's a signal when there really isn't a special cause. And the math behind the control limits is meant to minimize the number of times that occurs. And if I remember the number right, with this math, you're going to get a false signal about 1 out of every 300 and something times. So there may be that occasional time where you're looking for a signal that's just not there. I think that's way better than always looking for a signal when the chart tells us it's noise, when it's common cause variation. So again, that's where those Western Electric rules are designed to help us and strike a balance in how we set those control limits.
Okay, we have another question. How do you set up the control limits on a process where you have limited or no information?
Well, I mean, if I'm hearing the question right, I mean, if there's no data, we can't even do a run chart, yet alone SPC. So if I think back to the example, the picture I showed of the laboratory data, let me just pop this back up. The hospital's data infrastructure generated, or really mandated, monthly reports, monthly charts. And a lot of this was generated by a quality department and I believe just given to the lab. To generate the daily charts, they actually had to do some work locally. They had to tie into the laboratory information system. They had a black belt on the team actually generate the data queries and pumped things into the spreadsheets that we set up. I mean, they had lots of individual data. They could have printed a big, huge report of every turnaround time for every individual test, but it took some work to be able to create, a daily number for each shift. So, in my experience with hospitals, too much data isn't always the problem compared to manufacturing and other industries. That's one way where healthcare is trying to catch up. So we have the data so that we can look at it the right way and hopefully make good decisions.
Okay, so we've had a lot of questions. I'll go ahead and answer this one. Where can I get the printouts from today or the slides? And so again, we'll send out a link to these slides and to the recorded version of the video within a couple of days.
I'll put that out on SlideShare today.
Yeah. Okay, so let's see. Let me go to an email question. Is it better to measure events or time between events? For example, when measuring orders received from clients, is it better to measure number of orders received by a client in a month or time that elapsed between orders? It's kind of a confusing question. I might have to think about that one a little bit.
Well, yeah, I mean, I think I understand the question. I don't know if I have a great recommendation on that one, though. If we look at number per day or time between, I think that's honestly, that's a question. If I was working someplace, I would punt and go ask my local black belt, I think.
Yeah. Okay. Yeah. Again, we're just getting pummeled, and I don't even. They're all good questions. So try to find maybe here's a kind of a. I don't know if this one is meant to be a good-natured or what, but this individual wants to know if these concepts of control limit or control charts and Lean and Six Sigma can be utilized to square away the government and the United States. So it's kind of a, I guess maybe I'll just kind of rephrase it. You know, I guess to get your opinion, Mark, not to get political, but what are your thoughts on using continuous improvement concepts in you know, in the world of politics?
Right. Well, yeah. I mean, I think I would separate. We talk about government as opposed to politics. I mean, you know, there are, you know, candidates. I mean, this should be a bipartisan thing, but because of the Republican primary season, because that's where the political discussion is happening. You know, there are presidential candidates who have spoken up in favor of the use of Lean Six Sigma in government. And I think, you know, if we look at everything being a process, I mean, one thing I've blogged about before is the amount of time it takes to get a passport from the federal government. And it's weeks upon weeks upon weeks. And if we, you know, I'm sure if we look at it as a value stream, that it's mostly, you know, batch and queue waiting. It's mostly delay. It can't possibly take 8 weeks to physically produce the passport. So I would absolutely, I would be very certain that you could use Lean and or Six Sigma to improve the flow in that system to get passports to citizens more quickly. I think, you know, improving service, improving flow, preventing delays would be a great use of continuous improvement principles in government. I've talked to some people who've actually done work in government who say from a government culture standpoint, it can be challenging that quote-unquote cost savings don't always necessarily materialize in terms of budget reductions. You know, we see dynamics like that in other settings. So, you know, I wouldn't frame Lean and Six Sigma for government the way these candidates are in terms of saying we're going to get huge cost savings in government. I would frame it in terms of improving quality and improving service as being, I think, more realistic goals. And if we can actually, you know, reduce budgets and do more with less, then great.
Very good. Okay, so let's do one last question, and then Mark and I will take these questions offline and send those out in the podcast. I had a couple people that joined a few minutes late, and they missed your slide on Wheeler's slide, or the slide on Wheeler's book. So maybe can you flip back to your start of your presentation and show them the title of that book and what it looks like, Understanding Variation book. Yeah. So yeah. So
it's very readily available, you know, via Amazon and other online book outlets.
Yeah. Very good. Okay. Well, listen, we're going to stop it there. We've been right at an hour, and I want to again thank everybody for coming on. Mark's been great 2 times now. I think we've got lots of really good feedback. So thank you, Mark, for that. We do have some more webinars scheduled. In the near future here, so everybody that's on this one will get an email with some information on those if you're interested in joining those, and hopefully we'll get Mark back on again. We're actually talking about doing something that might be kind of interesting, more of an experiment, doing more of a Q&A type webinar where people can just kind of ask anything related to Lean or continuous improvement. So Mark and I might tag team that one. So look for that. We welcome your feedback, and if you have ideas for future webinars, definitely let us know. So, Mark, do you have anything to wrap up with?
No, that's all. Thank you, everybody, for taking time out of the day, and to Ron and Gemba Academy for giving me the chance to present today. Thank you.
All right, very good. Okay, everyone. So look for an email from us within a couple days with the slides and the recorded version of the video, and we'll try to get this podcast done as well. Okay. Thank you.